Hi everyone. What I'm going to do now is I'm going to review the classwork for Tuesday, April 14th. So this is kind of the second surface area assignment I gave you guys. And what I want you guys to do is, first, I want you guys to watch these two YouTube videos, and then we'll go through the problems. If you want to look at this problem here, my recommendation is to go back to the work from April 13th. I have a video going over a rectangular prism. This is a rectangular prism because basically it's a prism with rectangles on top and bottom. Well, this is actually a square, but either way, it's a rectangular prism. So, same thing with this here. Another rectangular prism problem solving surface area. I would go back to the video I made for yesterday's work. I want to give you guys a chance to look at this. This is the problem I'm going to do today. So if this is a rectangular prism because there are rectangles in there, this is what we call a triangular prism because we got a triangle on top and bottom, and then the sides kind of go up like that. So for this problem we have, what it says is an artist is building a pedestal out of wood that will be used to display a piece of sculpture. She plans to cover the pedestal with tile. How much tile will it take to cover the pedestal, including the bottom? So basically, it's just a classic surface area problem. How much do we need to cover the whole thing? So with any surface area problem, I think the thing you want to keep in mind is, well, like, what's our shape? This is called a triangular prism. And I think, like, you don't want to memorize too much, I think, with this stuff. I want to memorize as little as I can. Let's just kind of picture a triangular prism. It looks like this. We got a triangle on top, triangle on bottom. So, and the rest are rectangles. So basically, how many faces are there? There's one on the top, one on the bottom. We got one, I guess, in front, and then two over here in the back. So the triangle has three sides, so that means three rectangles. So that's 1, 2, 3, 4, 5. So we have 5 total faces. So we have a triangle on top and a triangle on bottom. Are those two triangles the same? And yes, they are. That's the definition of a prism, is that it has to be on the same at the top and the bottom. So we have two, well, actually, I'll write it out like a number. So we have two triangles, two equivalent triangles. And what shape is this in the front? I guess I'll kind of outline it like that. What shape is that? That is a rectangle. And then let's kind of look back here as well. What shape is this? Also a rectangle. And then this, also a rectangle, if you see that. So what we really want to do is we got two rectangles on the back and then one in the front. So we got 3 total rectangles. Now, are any of these rectangles the same? So to figure that out, we actually have to look at the triangle itself. We have this length is 5, this length is 5. And then to find this length here, we got to look down. It's actually 6. So I'm going to add that up here. So we have a length of 6 here, a length of 5 here, and a length of 5 here. For each of the rectangles, the width is 12. So we have a 6 by 12 rectangle, a 5 by 12 rectangle, and a 5 by 12 rectangle. So basically we have 3 total rectangles. So 2 triangles, 3 rectangles. Those are our 5 faces. And just in parentheses, for our 3 rectangles, we have 1 6 by 12 rectangles, and we have 2 5 by 12 rectangles. And that's because our triangle up there is an isosceles triangle. Isosceles triangles mean that 2 of the sides are the same. If we add a scaling triangle, which means none of the sides are the same, that means we'd have 3 different rectangles here. Which wouldn't be a big deal, it'd just be one extra step. So we got 2 triangles, 3 rectangles. What I want to do first is let's find the area of all the rectangles. And to do that, what I think I'm going to keep a tally over here. At the end of the problem, when we calculate our surface area, we're going to have to add everything up. So we're going to add up each rectangle and each triangle. So we should be adding up 5 total numbers. Some of them might be the same. So with our rectangles, so let's think about rectangles for now. So let's see where to go. For rectangles, area is equal to the length times the width. So for a 6 by 12 rectangle, that means the length is 6, the width is 12, or vice versa. So for this triangle, that means we just got to do 6 times 12. 6 times 12 is equal to, what is that, 72. So basically what I want you guys to think of is like, we just found this front rectangle. Yeah, we just found that rectangle in front. So what we're going to do now is we're going to find the rectangle, one of these 5 by 12 rectangles. So that, again, a 5 by 12 rectangle will be this much. But you got to remember that there's 2 of them. There's one here, and there's also one right here beside it. So for that one, that's going to be 5 by 12. It doesn't really look like a 5, but it is. 5 times 12. What's 5 times 12? Nickels are 5 cents. If you have 12 nickels, you have 60 cents. So 72 and 60. Let's make this clearly a 0. 72 and 60. But we got to remember there's 2 of these. 1, 2. So let's kind of make up our surface area tally. We got 72. This is from our 6 by 12 rectangle. Then we got 60. Then we got another 60. So that's 3 of our faces so far. And now we just got 2 more. That's our 2 triangles. Remember, our 2 triangles are going to be the same. Let's switch colors. Let's see. So for our 2 triangles, let's look at that. So for area of a triangle, area is equal to 1/2 base times height. So that's 1/2 times the base times the height. Think of that, it has half of the base times the height. Or you can think of it as base times height divided by 2. I think that's the easiest thing to do. So base times height divided by 2. I'm going to write it like that. Base times height divided by 2. So these 2 expressions are equal. Base times height divided by 2, 1/2 base times height. Multiplying by 1/2 is the same thing as dividing by 2. So let's go back to this. Okay. So we have 2 triangles. So again, the base of the triangle. So it gets confusing because a lot of times with surface area problems with 3D shapes, sometimes they'll show an entire face as a base. I like to try and avoid that. So I'm just talking about this triangle here. Just this triangle here. And what I'm going to do is I'm actually going to copy that triangle, bring it down. I'm going to do the best I can here. Let's see. 1, 2, 3. 3 sides of this triangle. And you can think of that as a little bit more pointier than I drew it. But anyway, the base, the bottom of the triangle is 6. And they said over here, the height of the triangle, you can see because I have that box there, that this is a vertical line. The height of the triangle is 3. So 1/2 times the base times the height, or base times height divided by 2. So that's going to be base is 6. So I'll say this is the base. Remember that 3 there, that's the height. So 6 times 3 divided by 2. That's 6 times 3 is 18 divided by 2. What's 18 divided by 2? That is 9. So the area of the triangle is 9. So this area is 9 and this area is 9. And remember, we got two triangles here. So that means, let's go back to the purple. That means we got 9 and 9. So those are our 5 faces. To get the total surface area, we just got to add up all of them. See if I can... Okay, so 2 plus 9 plus 9, 9 plus 9 is 18, plus 2 is 20, so I'm going to put a 0 right here. This is a 2. 2 plus 7 is 9, plus 6 is 15, plus another 6 is 21. So our total surface area will be 210, and because we're in inches right here, surface area or any area problem will always be in units squared. So because we were in inches, our area will be in, oh, whoops. That was weird. Let me erase that. Our area will be in inches. Okay, I get what's going on. I'm going off the screen. All right, drum roll. Inches squared. So that's our answer. I'm going to highlight it. This is our answer. 210 square inches, or 210 inches squared. All right, so hopefully that'll help you guys out with solving the rest of these problems. Again, I think for any surface area problem, you really want to break it down into each of the faces. So how many shapes are there and what shapes are there? So for a triangular prism, you know you have 2 triangles and 3 rectangles.